So
Why are you doing this right now?
I said there were 8 laws. That's true, but it depends how you define it. So I would say there are 7 laws, but the last one you can split into 2. So I'm going to call it Law 7, Part A. Okay. So the question is, what if I take something like this? Thank you. What's about 3 to the power of half? Okay, so some of you met this before and you're right, you're saying the right things, but again I'm going to ask you the question, how could I deal with this? So what I could do, at the moment we don't know what this is equal to. Now in maths, when we don't know what something is equal to, we know it's equal to x. Okay? That's very easy. We set it equal to x. Okay? And I look at this and I go, okay, well look, I don't want 3 to the power of half, I want it to be a nice whole number, because if it's a nice whole number, I can deal with it. Yeah? I can deal with it. So what can I do to this to turn the half into a nice number? So let me look at your first 3 laws that we use.
Equals.
I could square it, right? Because if I square this, if I square both sides, okay, if I square both sides, what will the left-hand side become? What would I do to these 2 numbers? Yeah, exactly, because I would multiply them together. I'd say, what's half of 2?
2.
That's 1, right? Yeah? And then on this side, I just end up with x squared. And of course, I know that 3 to the power of 1, that's like law 4. What's that equal to? Just 3. Okay? So look, I've transformed this into a completely equivalent thing. I've just rewritten it in a slightly different way. So I started with 3 to the power of a half equals something I don't know. And I've got to a point, through pure logic, using the other laws of indices, that said to me, okay, 3, that's got to be x squared. So if I get rid of all of this then, and I just write these 2 things next to each other, let me do it in green, so I know 3 to the power of a half equals x, and I know x squared, 3 equals x squared. Let's keep it consistent. Okay, so these are now the 2 things which I have.
And 3 squared equals x.
Exactly. So I could rewrite this thing by taking the square root of both sides. Now, strictly speaking, I should be taking the positive and negative root, but let's gloss over that for the time being. So if I wanted to rewrite this equation, it would become the square root of x. Okay? Now have a look. I know x is equal to 3 to the power of a half. I also know x is equal to the square root of 3. That must mean then that 3 to the power of a half is the square root of 3. Okay? That's a proof. Nice, happy proof. Right? So, what's actually happened here? Can we actually think about this? What would 3 to the power of a third be? Can anybody wonder? So why is 3 to the power of a half? How would I get from a half to a square root? What would 3 to the power of a third be? Can anybody think through the same logic? Good. That would just be the cube root of 3. Okay. What about 3 to the power of a fifth? Yeah. What about, let's change a 3 to a different number. Let's take 10 to the power of a 7. What's that the same as?
Yeah, 7 squared.
Do you get the idea? Yeah? So in other words, I am looking at this denominator, and this effectively becomes the nth root which I'm taking. So here I have a denominator of 3, that became the 3rd root. And here I had the denominator of 5, that became the 5th root. There I had a denominator of 7, that became the 7th root. So in general then, if I had a to the power of 1 over n, what would that be the same as? Nth root of a. Is that okay? So that is law 7 part A. If I have a number raised to a fraction, that denominator becomes the whatever root it is. Okay, so if I had a raised to the power of 1 over n, that becomes the nth root of a. Okay? And of course you can apply exactly the same proof to all of these I did for the first one. I hope none of you are walking home. Okay, it might stop in half an hour. Alright, good. So that's law 7 part A. Now what if I wanted to extend it? What if I wanted to extend it? And that's what I get for law 7 part B. What if I said, well okay, that's fine as long as the numerator of my fraction is 1. What if it's not? What if it's being awkward? What if it's like 3 or 4 or 5 or a different number? Okay. What if I gave you something like this? Okay. Now ordinarily, if this was 3 to the power of 1/5, from law 7 part A, what would that be equal to? 5th root of 3, right? So what's the difference between this and this? Agnes, you were going to say something?
You put it back in the square.
Absolutely right. So another way that I could rewrite this, is 3 to the power of 5th, all squared. You happy? Because by law 3, if I multiply those two things together, I get 2/5. Okay? 5th times 2 is 2/5. Okay? Now that becomes, well, okay, that becomes the 5th root of 3, I know that, all squared. Okay? But what if I did it the other way round? What if I said, actually, I don't want to write it as 3 to the power of 5th, all squared? What happens if I wanted to write it as, let me do a different colour. Let me try green. What if I wanted to write it as 3 to the power of 2, all raised to the power of 5th? Okay? That's equally equivalent because you're happy, if I multiply 1/5 by 2, I get 2/5, and if I multiply 2 by 1/5, I still get 2/5. So I'm just breaking it up in a different multiplication. This would then become 3 to the power of 2, all 5th rooted. Okay? So what I'm trying to say, it doesn't matter which order you do. Okay? Whether you take the root first, then leave the power, or whether you take the power first, then take the root. It doesn't matter which order. And sometimes, well, either order can be useful. For example, if I take 4 to the power of 3/2, what would this be equal to?
2. This has 2 of 3.
Okay,
8.
so which one are you doing first? You're doing the root or you're doing the power? The power, okay, so you're saying 4 to the power of 3 and then square rooting. So you're doing it that way around. Okay, so what's 4 to the power of 3?
64.
Okay, and what's the square root of 64?
8.
8. Okay, now what if I did it the other way round? What if I did the root first and then I did the power afterwards? Okay, let's do it that way round. So what's the square root of 4? 2. And what's 2 to the power of 3? 8. Okay, so you get the same answer, but which one is easier, do you think?
The first one. Second
Really?
one.
Okay, so it's a mix, that's good, it's a mix. I would argue the second one is easier because I think it's always easy to make the numbers smaller before you make them bigger. Do you agree with that? Yeah? But I mean, it's up to you. If you've got a calculator in front of you, either one works. You're good. We happy? Thumbs up? Okay. Maybe if you do some questions, we'll be okay with this.
The first part is -2.
Okay, that's really good. So we can extend this, we can combine multiple laws together. Let me just generalise this one first, then we'll come on to that. Instead, right, good. So if I did a to the power of n over m, how could I rewrite that? 2 ways. I could either take the mth root of a and raise all of that to the power of n, that's fine. Or I could take a to the power of n and then take the mth root of it. Okay? No? Let's do some more questions then. Let's do some more questions. So, can I rub this stuff off and let's do questions? Okay, so, okay, here we go. Let's take 9 to the power of 3/2. Okay, so Megan, what would we do with this denominator? What would it become? You happy it would just become the square root of 9? Yeah? And then we raise all that to the power of 3. In fact, let me get rid of these brackets because maybe it's confusing you. Okay, so the 3 just kind of stays there and the denominator just comes down to become a root. It's exactly the same as law 7 part A. We're okay with that one? Yeah? What's the square root of 9? What's 3 to the power of 3?
24.
You sure?
Yeah.
Good, okay. What about this one? 81 to the power of 3 over 4. What do we do with this Pascal and Euclid? Good. Good. Now what's the 4th root of 81?
36.
Careful. Anybody help? What's the 4th root of 81?
37.
That's the answer. What's the 4th root of 81? It's 3, right? Yeah, and then raise it to the power of 3. You get 27. That just happened to come out the same. It's just a coincidence. Is that okay? You sure? Let's do more. Okay. What about... Yes. Why is it 3 to the power of 3? Because here what we did was we took the root first. We took the 4th root of 81 first. And you said that 4th root of 81 is just 3. And then we just had the cube left over to do. Let me look at it this way. What about if we took 8 to the power of 2/3? Okay. Tell me how I'd rewrite this.
3, 8.
Good. The 2 would just stay. Okay. Now what's the cube root of 8? What's the cube root of 8? Fatima, what's the cube root of 8? 2. Good. Raise it to the power of 2. So what's 2 squared? What's causing issues?
I don't understand why the root of 3 is a cube.
Because we've already done that. I've dealt with the cube root of 8. So I've rewritten it first. Okay, then I'm doing it in 2 stages. I'm doing the cube root of 8 first, then I'm doing the squaring. So I do the cube root of 8 first to become 2, then I'm doing the squaring to become 4.